Okay, okay. So we are going to start this aldehyde, ketones, and carboxylic acids, right? So
Yes.
this chapter as carbonyl compounds. This chapter is also known as carbonyl compounds. So what is this carbonyl compounds? So any functional group, Firaz, which have C double bond O in any functional group, and this group presents C double bond O, that represents that it is carbonyl compounds. Is that clear?
Yes.
Okay, so if I am going to write this, as you can see, this is your carbonyl. This is also your carbonyl. This is also your carbonyl. And this is also your carbonyl. All this that I am writing is carbonyl compound because every functional group has C double bond O group. That's why. And I can also write like this. This is also carbonyl. And this is also carbonyl. Now I want you to tell me the name of this first. Which functional group is this? First, second, third. Can you tell me? Starting from the first.
First is a carbonyl compound.
Carbonyl compound, all of them are carbonyl compound because every group has C double bond O. But if you are going to be a specific, which functional group is this?
Ketone.
No, ketone is
Carboxylic
best.
acid. That's carboxyl.
This is your carboxylic acid. This is your aldehyde. When you have C double bond OH, that is aldehyde. When you have C double bond O and both the side are alkyl group, that is ketone. And when you have one side alkyl group and another side C double bond OOH, that is carboxylic acid. Now, can you tell me about this? The fourth one. Do you know, yes or no?
Halide.
Halide is for X minus. Halogen X, if you are going to put negative side there, it becomes halide. So basically it is acyl halide, not halide only. This is your amide. This is your acetic anhydride. This is what? Anhydride or acid anhydride. This is your ester. Is that clear, Firaz?
Yeah.
So you need to recognize the functional group. Okay. Can I change the slide?
Yes.
Okay. Now, because some of this compound which has common name is quite famous and we need to keep it in mind. So first of all, I'm going to go with this IUPAC nomenclature. IUPAC nomenclature. So, are you aware of the nomenclature of aldehyde and ketones? Because we are going to deal only here with aldehyde and ketones. So I think you can do the nomenclature. If you are unable or if you don't understand the nomenclature, how to write the IUPAC nomenclature of aldehyde and ketone, just let me know. Will you be able to solve it? Write the name of the following compounds. Yes or no? Please do respond. Yes,
So
Firaz.
first one is ethanol.
Very good. The first one is ethanol. That's good. What about the second one?
3-bromo, 2-methyl hexone.
Hexone. What is this name? Hexone or hexane? Are you trying to say hexane or hexone?
No, it'll start with oxo then.
Okay, wait a minute. Where is the functional group? Right here? Yes or no? On the right hand side?
Yeah.
So can you tell me, Firaz, that which functional group is this?
That's an aldehyde.
Aldehyde. And can you tell me which functional group in the first compound?
Aldehyde.
Aldehyde. And for aldehyde, you used al, which is
Al.
right?
Yeah.
Al. Okay. So you are going to write the numbering first: 1, 2, 3, 4, 5, 6, 7. As we have studied the nomenclature of alcohols, that we are going to give preference to the functional group. That's why I did numbering from right to left. Now, when you are going to write the name, you have to write it in alphabetical order. So it will be 4-bromo,
3-methyl,
3-methyl, and then comes 7, that is hapt, and all are singly bonded haptane, 1-ul, or you can write up to this will be same haptane that you have just said. Got it?
Yeah.
Okay, what about the third one?
Cyclopentanone.
Cyclopentanone. It was right. If CH3 is not there. Okay,
3-methyl.
1, 2, 3. Always write the name of the substituent or branch. 3-methyl cyclopent, and all are singly bonded. So pentane, 1-on or pentanone. Very good. What about the fourth one?
Phenyl.
What phenyl? 1, 2, 3. Position is very important.
1-phenyl.
So you are going to write the numbering like 1, 2, 3, and you can see 1-phenyl, and then in the parent chain 3-carbon prop or a singly bonded propane, and 1-on or propanone, right?
Yeah.
Okay, what about the fifth one? You are muting, unmuting. You are not audible, Firaz. Firaz.
So this will be
There is no branch, so we will directly jump to the parent carbon.
butene,
Pent.
pentane.
No,
Two.
not pentane. Just write pentane. Sorry, pent. Then come to the nature of the bond. Two in
Double
pent,
bond.
two in,
Two in.
one al. Got it, Firaz?
Okay.
What about the sixth one?
Cyclohexane.
It is cyclohexane, and if you are not counting the carbon of aldehyde, then it will be carbaldehyde. So you are going to write cyclohexane carbaldehyde. Got it? Firaz?
Yeah.
Okay. Now there are some more to go. CH3, CH2, C double bond O. And then comes CH2 and then C double bond OH. This is the first one. Then comes your second one, CH3, CH3, C double bond O, CH3, and then CH3. The third one is this. The fourth one is this.
Third one we just did right.
What you just said, third one is?
Third one we did right.
You are not audibly clearly. Please.
We did the third one right.
Third one. No, it is cyclohexanol carbaldehyde. We did this part. This one. This is cyclohexane carbaldehyde. And if you are going to put double bond at alternate position, it becomes benzene, right?
Yeah.
There is a difference between this cyclohexane and this alternate position double bond. This is benzene, right? So this is different.
That says benzaldehyde.
Benzaldehyde, not benzaldehyde. See, if you are unable to count the number of this, so we can write benzene carbaldehyde. Benzene carbaldehyde, and its common name is benzaldehyde, which is treated as IUPAC nowadays. Is that clear? Benzaldehyde was its common name, but now it is treated as IUPAC also. Originally, its name was benzene carbaldehyde. Are you getting my point, Firaz?
Yeah.
Now look at this 1, 2, 3. Actually, if you are going to numbering from here, so it comes to end here, but this carbon will not be able, you will not be able to count this carbon. So what I just did, let me show you the whole scenario. As you can see, if you are going to count it 1, 2, 3, 4, 5, but you are not able to count this carbon. So what I did is very simple. I didn't count all the carbon of all this aldehyde. So what it will be 1, 2, 3, and for 3 carbon it is propane, and I'm going to write 1, 2, 3 tricarbaldehyde. Got it?
Yeah.
Now you can see I'm going to now count this number 1, 2, 3, 4, or you can write 4 nitro benzene carbaldehyde, or I'm going to write both the name 4 nitro benzene carbaldehyde, or either you can write 4 nitro benzaldehyde. Got it?
Yeah.
If you're going to numbering it from anywhere, it will be same 1, 2, 3, 4, 5, and you can see 2 methyl group is there. So it will be 2, 4 dimethyl. How many carbon in the parent chain? 5. So pent in 3 on. Can you do the first one? Yes or no?
Three also. Pentanol.
3. Very. 3 oxo pente.
Pentanol.
Very good. So you are going to see there are 2 types of functional group. One is aldehyde. This is your aldehyde, and this is your ketone. And in nomenclature, aldehyde we give preference. Aldehyde is junior than ketone. So this ketone will be junior, and since it is junior, we will be treating as substituent. So we are going to write 3 oxo. The when it is used as prefix, its prefix name is oxo. So 3 oxo pentanol. So it's all right. Can I change the slide?
Yes.
Okay. So this was the nomenclature of aldehyde and ketones. We will do the nomenclature of carboxylic acid when we will be completing this aldehyde and ketones. So write a topic that is the structure of carbonyl group. So we are only dealing with the carbonyl group here. As you can see, if you have a carbonyl group like this, you know this is more electronegative, so it will go like this. So it will have negative charge, and this will be the scenario. Here the hybridization is sp2, that means trigonal planar, and again this will have the same hybridization sp2, and in sp2 each the bond angle will be basically 120 degree. You know that, right? From class 11, 120 degree it will be. This is one of this is also 120 degree. They will be trigonal planar. The compound will be trigonal planar. Let me know when you are done with this. Are you done with this?
Yeah.
Okay. Let's start the preparation of aldehyde and ketones together first, and then we will differentiate, because these methods are the preparation of aldehyde and ketones both together, depending upon the reactant on preparation of aldehydes and ketones. And mostly from this, This preparation we have already studied mostly. Like the first one is by oxidation of alcohol, by oxidation of alcohols. So I don't need to write all the reaction because we just covered that primary alcohol, if you have 1 degree alcohol, or you can say primary alcohol, and if you are going to do oxidation or using oxidizing agent, it will be converted into aldehyde. In the previous chapter we did this or not,
Yeah.
Firaz? And if you have 2 degree alcohol,
Ketone.
or so it will be directly converted into ketone. If you are going to use an oxidizing agent, PCC or CrO3, it will be converted into ketone, right? So these are the reactions that we have already completed. So can I change the slide? Go for the next.
Yes.
Great. Now the second, wait a minute, sorry. Now the second method is basically by dehydrogenation of alcohols. You have also seen that if you have a primary alcohol, and if you are going to use this alcohol in vapor form and pass over copper or Ag silver at 573 Kelvin, the hydrogen from here and hydrogen from here will be eliminated, and this is what we get, aldehyde. And if you have secondary alcohol, same, then the hydrogen from here and hydrogen from here will be eliminated, and you will be again getting ketone. So that means secondary alcohol will again give you ketone, and primary alcohol will give you aldehyde, right?
Done.
Very good. Now see, the third preparation is from hydrocarbons, and this reaction you have already studied it in class 11. From hydrocarbons, in which the first method is ozonolysis of alkenes, by ozonolysis of alkenes. by ozonolysis of alkenes. Ozonolysis, that means you are going to react an alkene with ozone followed by ZnH2O, and it will give you either aldehyde or ketone depending upon the reactant, which type of alkene you have taken. Is that clear? So first of all, I'm going to take a very small alkene, that is ethane, a smallest alkene, and I'm going to react in this with O3 first. Now see what will happen here. So what you need to do is just write the rest part same and don't show the double bond and make a home around the double bond. Are you getting my point? If there is another bond other than double, then you can show, and the double bond, just make it like a home. Firaz, are you there?
This is a structure.
Yeah, along a double bond, you need to form this home type structure if it is going to react with O3. Is that clear? Along double bond. I'm just explaining the reaction, that how the reaction will take place, what will be the product for. Okay.
Yeah.
So make a home and then break a home. Just break this and this. This will be evolved. And in the second step, you are going to react this with zinc dust and H2. So what will happen on the left hand side, you can see you have got this CH2O. That means H and O. With it was single bond, but carbon makes 4 bond. So it will be like this. And another is same. So C double bond OH. So you can see this gives ozonolysis of ethene gave you 2 mole of methanol. This is your methanol, and this is also your methanol. Yes or no? You can see this part is your basically methanol.
Yeah.
As you can see, this part is your methanol. So please do write it.
This only makes an aldehyde, right?
No. Depending upon the reactant, it can make a ketone also. We will take some examples, then you will get it. Now see, have you written the topic of this? All this?
Yes, you can scroll.
Okay, now see here. If you have propene or any alkene, what you need to do, just follow my instruction. If you are going to react this with O3, just make a home alongside double bond. The rest part will be as it is, and like this, and make a home and then break the home like a structure. And now what you are going to do, just break it and pass it through zinc and H2 followed by water or hydrolysis. What will happen? You can see this is your CH3 and this is your CH, which is ethanol, and in you can see CH2O. CH2O is what? It is basically HCHO, which is methanol, and this part is your ethanol. Yes or no? It again give you aldehyde. Depending upon the reactant, you will also get ketone. So I'm going to give you a question. You need to do. Wait a minute. Just write all this. You're going to react with O3, and then you will be getting something, and then followed by zinc, dust, and water. Please do it. Are you done with this? Ross, let me know if you are facing any type of problem in this. Firaz, are you done with this? Firaz,
Yeah.
what is the name of the product that you have got?
Ethanol.
Never know. Ethanol. Did you say ethanol? Only one product that you have got? Firaz, please do respond so that I'm going to see what you need to do. First, if you are going to react this with O3, what it will be? CH3, CH3 here it will be, and then the rest part is CH3. You are going to make a home here like this and break the home like this. So this will be broken like this and this. So what will be the product here? CH3, CH3. As you can see, carbon and oxygen will be double bond because carbon makes 4 bonds. So in this way you can take it. And the rest part is CH3. On the right hand side it is CH3CHO. So basically this is propanol, that is ketone you will be getting, and this is your ethanol. Okay, Firas, is that clear?
Yeah.
Okay, can I move to the next part? So let's start this preparation of aldehydes. So see, what is this preparation of aldehyde? So the first is basically, especially we are going to do the preparation of aldehydes. Previous preparation was mixture of aldehyde and ketones, and depending upon the reactant, it will either give you aldehyde or ketone. So the first here is from acyl chloride, or we can say acid chloride. acid chloride. So basically, it's a very
We'll
important
do that
reaction, and
hydration of alkynes.
we will do that. We will do that. Okay. Is this clear? From acyl chloride.
Yeah.
So it is an important reaction because it is a name reaction. Acyl chloride or acid chloride, basically its name is also acid chloride, is hydrogenated. That means hydrogen will be added. Hydrogenated over catalyst palladium sulfate on barium sulfate. And this reaction is basically known as Rosenmund reduction. Rosenmund reduction. As you know that addition of hydrogen is a reduction. That's why, as you can see, we did hydrogenated. That means hydrogen will be added. So that it is known as Rosenmund reduction reaction or Rosenmund reaction. So acyl chloride, I am going to write it. So it will be like this. C double bond O and here Cl and it is H2 PD BaSO4. So what will happen here? You know that chlorine will be eliminated and one of the hydrogen from here will be taking place of chlorine. So it will be benzaldehyde. It will be benzyl. And hydrogen that is left here and chlorine that is eliminated from here will combine to form HCl. And this is your benzaldehyde. Is that clear?
Yeah.
Okay. Can I change the slide? Oh, the one part from 11 that is left by dihydration alkynes. Ethene will give you aldehyde and of ethine. Oh, just write it and then let me know. I'll explain that reaction. Are you done with this?
Yes.
Okay, see. The one that you just told me, I forgot to write about it. That is basically from this part. Wait a minute. Oh, I needed to write it here. So I'm going to write it here. As you can see, the second part of this is by hydration of alkynes. By hydration of alkynes. So basically, whenever you are going to do hydration of alkynes in the presence of H2SO4 and HgSO4, then what we will be getting CH2, we are going to do it for alkynes. That means CH triple bond CH. And if you are going to react it with water hydration in the presence of H2SO4 and HgSO4, it will give you directly CH3CHO. Other than this, if you are going to take CH3, C triple bond CH, and if you are going to do the hydration of this, you will be getting ketone, CH3, C double bond O, CH3. This is what you will get. So always remember, ethyne will be converted into ethanol, but other alkenes like propine will give you propanol, ketones. It will always give you ketone. So this reaction is also very important.
What about methane?
We don't have methane.
Oh yeah, sorry.
See, yeah, the lowest ethene is the lowest alkene is ethene, the smallest alkene. If you are going to talk about a smallest alkyne, then it is CH triple bond CH. But a smallest alkane, if you are going to talk about it, is methane, that is CH. Okay. Let me know when you're done with this.
Yeah, I'm done.
Very good. Now see, come to the preparation of aldehyde. We just did from acyl chloride. Now we are going to do the next stage from nitriles, that is also known as cyanide, and esters. You are aware of these two functional groups, nitriles and esters. And from nitriles, there will be a name reaction, that is a Stephen reaction. So I'm going to write the some sentence about it. Nitriles are reduced to corresponding imine. You can treat this imine as functional group, but we don't need to study about this imine. And with the help of basically stannous chloride, SnCl2, basically stannous chloride, in the presence of hydrochloric acid, which on further hydrolysis give corresponding aldehyde. So it's very easy. As you can see, I'm going to write it. So from nitriles and ester. So first of all, we are going to do it from nitriles, and this reaction is known as, this is very important to write. This reaction is known as a Stephen reaction. This reaction is known as a Stephen reaction. So please do write up to this, then I will explain the reaction. I'm just going to write the reaction first in a better way, and then I'll explain the reaction as well. This is your amine, RCH double bond NH, which on further analysis, hydrolysis, it will give us aldehyde. So first write it, then I'll explain the reaction. Let me know when you are done with this, Firaz.
Done.
Very good. Now see how the reaction took place. So as you know that RCN is like this, RC triple bond N. And if you're going to react this with stannous chloride in the presence of HCl, so what will happen? In order to add hydrogen or reduce it, one of the bond between carbon and hydrogen will be broken or cleaved, and now hydrogen will be added. So it is double bond and NH. Now you are going to do the hydrolysis in the presence of acid. It is so H plus and OH minus. No, you also know that this will have negative, this will have positive sign. So this will go and hydrogen will be eliminated and it will form basically RCHO, and H plus will go here and it will form NH3 as a byproduct. But we need to focus on the main product, which is aldehyde. Is that clear?
Yeah.
Can I change the slide?
What is imine?
Imine is this. This is a this is imine. This is nitriles and this is imine. Imine is also a functional group like nitriles. We say imine is this. Imine is CH double bond when carbon and nitrogen has double bond. Okay.
Yeah.
Can I change the slide?
Yeah.
Okay. Now see, I'm going to give you a question on this, and I think you can do this easily. Also, there is alternate method to prepare aldehyde from nitriles by using dibyl H. By using dibyl H. What is dibyl H? So basically, this is this is diisobutyl ammonium hydride. So I'm going to write it nitriles. Write with me. Nitriles are selectively reduced by diisobutyl. Selectively reduced by diisobutyl aluminium hydride, which is also known as, in short form, we use dibyl H. Dibyl H, or we also can write ALH IBU old ones. Reduced by diisobutyl ammonium hydride to imines followed by hydrolysis. Followed by hydrolysis to give aldehydes. So it's very simple. Previous method was same. You are going to treat this nitriles with stannous chloride in the presence of HCl followed by hydrolysis. Now the alternate method is you are going to use this nitriles with dibyl H followed by if you are going to react this dibyl H with Nitriles with double H, you will be getting an imines, and imines followed by hydrolysis, you will get aldehyde. So we can write RCN. In the first step, you are going to use this ammonium hydride diisobutyl. So diisobutyl, and followed by hydrolysis. So it will be directly giving you RCH. So there are two methods. Is that clear?
Yeah.
So please do write it. Let me know when you are done with this.
Done.
Very good. Now I'm going to give you a question on this. If I'm going to give you this, can you please tell me the name of the final product? Are you done with this? Firaz, so Firaz, what you need to do is very simple. Just change the CN to CHO directly and you will get your product.
Yeah.
So this is what you have got.
Yeah.
Can I change the slide? No need to
Yes.
change the slide. So we are done with the nitriles preparation, and here basically similarly esters are also converted. Esters are also converted, or wait a minute. At the place of converted, it is good to use. Similarly, esters are also reduced to aldehydes with dival H. With dival H. So as you can see that this is your CH3, CH2, CH2, and this is your CH2, and this is your C double bond O, and then O, and this is your C2H5. And if you are going to treat this with dival H followed by hydrolysis in the same way, so what will happen here? It will be reduced. Here this part will be broken and hydrogen will be added to this and hydrogen will be added to this, so it becomes alcohol and this becomes aldehydes. So this will be basically CH3, CH2, 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 and then it will be converted into C double bond O and then H. Please do that. Are you done with this? Firas, are you done with this?
Yeah.
Okay. Now the next preparation is from hydrocarbons. From hydrocarbons. From hydrocarbons, and in this we have by oxidation of methyl benzene. By oxidation of methyl benzene, and in we can oxidize this methyl benzene in two separate ways. The first is by use of chromyl chloride. By use of chromyl chloride, which has a formula CrO2Cl, chromyl chloride. And this reaction is basically known as a tart reaction. So I'm going to write some points about this reaction. So basically, write with me. Chromyl chloride oxidizes methyl group to a chromium complex. To a chromium complex. It oxidizes the methyl group to chromium complex, which on hydrolysis gives corresponding benzaldehyde, and this reaction is known as Attard reaction. This reaction is known as Attard reaction. It is a name reaction. Please do write with me and let me know when you are done. Are you done with this, Firaz?
Yes. Yes.
Okay. Now see what will happen and how it's gonna take place. It's very easy. So there is a methyl benzene that is basically its common name is toluene. Its common name is toluene. So this is your toluene, or you can say that this is methyl benzene. And if you are going to react this toluene with bromyl chloride CrO2Cl2 in the presence of carbon disulfide CS2, then this bromyl chloride will be oxidized and converted into a chromium complex. As you can see, this will be CH. Two hydrogen will be eliminated. That means removal of hydrogen is known as oxidizes, and it becomes OCrO HCl2 cold twice. This is basically chromium complex. After formation of this chromium complex, you need to hydrolyze this. And if you are going to do hydrolysis of this chromium complex will be converted into aldehyde, and we will get directly our benzaldehyde. You can write the bond in this manner. This is also correct. So please do that. I'm waiting. Firaz, are you done with this?
Yes.
Okay. Now the next method to oxidize this methyl benzene is use of chromic oxide. B is basically use of chromic oxide. Chromic oxide. Chromic oxide, that means CrO. Now, directly I'm going to write the reaction. So this is your toluene or methyl benzene. And if you are going to treat this with chromic oxide in the presence of acid anhydride, at 0 degrees centigrade, 0 to 8 degrees centigrade, then this will be oxidizes to a complex or a compound intermediate, you can call it. So one hydrogen, two hydrogen will be eliminated, and same product will be formed. Only the difference is that this product is different. This will react in the same manner. Here two CH, only CH left, and here only CH left. But here there were chromium O2 Cl2. In this way it reacted, and now we have acetic acid anhydride. So here the intermediate form will be OCO CH3 whole twice. In the same way, you can see this is CrO2 Cl2. So this is your CrO2 Cl2 and hydrogen whole twice, and here it is OCO CH3 whole twice. And after getting this, if you are going to do the hydrolysis and heat, then this group will be eliminated and it will be converted into aldehyde. Please do write. Let me know when you are done with this, please.
Done.
Firaz, are you done with your pre-board in your exam school?
Not yet, sir.
Okay, no problem. Now the next method is basically by side halogenesis. So write this by side chain chlorination, by side chain chlorination, followed by hydrolysis, followed by hydrolysis, followed by hydrolysis. So it's very easy. Followed by hydrolysis. You can say if you have toluene or methyl benzene. So, and if you're going to react this with Cl2 in the presence of HNO, you know, this chlorine cannot go to the carbon which is sp2 hybridized double bonded. So it will go here and it will react twice, and two hydrogen will be replaced with chlorine. Now it will form CHCl2. After getting this, you are going to do hydrolysis at 373 Kelvin, 100 degrees centigrade, and this will be directly converted into benzaldehyde. This is what? This is your benzaldehyde. Please do write it. benzyl dehydrogenation. And this is your benzyl chloride. And this is your toluene. Are you done with this?
Yeah.
Now the last preparation of this aldehyde is basically the third one. This was the second one. It is by Gatterman Koch reaction. By Gatterman Koch reaction. So basically it is a name reaction in which if you have a benzene or substituted benzene, you know what is the difference between benzene or substituted benzene? Yes or no? Firaz, do you know the difference between substituted benzene and benzene?
Just
Am I
benzene
audible?
aldehyde, right? Substituted benzene.
No. Benzene is normal. This is your benzene, and substituted benzene, that means uh, if there is any other group that is attached with benzene, that is substituted benzene. Okay.
Yeah, I got it.
When benzene or its derivative, that means substituted benzene, you can call it, and its derivative is treated with carbon monoxide, and hydrogen chloride and hydrogen chloride in the presence of anhydrous ammonium chloride or cuprous chloride it gives benzaldehyde. Either it will give benzaldehyde if it is benzene, or substituted benzaldehyde if you have taken its derivative or substituted benzene. And this reaction is known as, it is a name reaction. This reaction is known as Gatterman Koch reaction. and let me know.